Ever get frustrated waiting for a delivery? I know I do.
Yeah?
Well, today we're diving into the tech that's going to make those late deliveries a thing of the past. Drone delivery systems. We're looking at Paul Brebner's talk from that Hong Kong conference. The guy actually built a simulation of this whole thing.
Wow.
It's not just about drones flying around.
Great.
It's about all the behind-the-scenes magic that makes it work.
Yeah, it's a fascinating look at how we can take these complex systems, drones, orders, deliveries, and make them all work together smoothly.
Using some pretty clever software.
Yeah.
All right, so first up, workflow orchestration. Paul uses this analogy of spinning like on a bike.
Yeah, just like a smooth high cadence on a bike means you're going fast and efficiently.
Right.
Keeping those tasks in order is key when you've got a whole fleet of drones making deliveries.
And that's where Cadence comes in, right? Uber's open source workflow engine. So it's like the brains of the operation, making sure everything runs on time.
That's a great way to put it.
Okay.
But it's more than just a scheduler.
Right.
Cadence is built to handle a massive amount of tasks at once, and it's seriously good at dealing with problems.
Okay.
Think about it. You don't want a drone glitching out mid-flight and just dropping a package, right?
Definitely not. So how does Cadence prevent drone mayhem?
Well, it breaks down each drone's job into these smaller activities. Let's say a drone loses connection while flying to a shop.
Okay.
Cadence is smart enough to restart that specific fly-to-shop activity, picking up right where it left off.
Okay.
No more drone crashes just because of a little hiccup.
So Cadence is like a super reliable autopilot, making sure those drones stay on track no matter what. That's pretty impressive. But we're talking about a whole system here, not just individual drones.
Yeah.
How does it manage all the orders coming in at the same time?
That's where things get even more interesting.
Okay.
Paul's system uses two separate workflows. One for the drone itself, and another one for the order it's carrying. And they actually communicate with each other.
Wait, so it's like two separate dances happening at the same time? How do they stay in sync?
They use these things called asynchronous signals to pass information back and forth.
Okay.
Imagine it like this. A drone starts its day at the base fully charged. Then it gets an order, flies to the shop, picks up the package, flies to the customer, drops it off, goes back to base, recharges, and repeats.
Okay.
Cadence is making sure both the drone and the order are on the same page every step of the way.
Okay, so we've got Cadence keeping the drones flying smoothly and managing all those steps.
Right.
But how does it actually talk to the orders coming in? That seems like a whole other layer of complexity.
Yeah.
It is. And that's where Apache Kafka enters the picture. Think of it as the air traffic control for this whole operation.
Exactly. If Cadence is like the choreographer for each individual dance, Kafka is the stage manager.
Okay.
Making sure everyone's in the right place at the right time.
Right.
It provides that communication highway between all those different workflows, keeping everything in sync.
Okay, so Kafka makes sure the drones and the orders are talking to each other.
Right.
But how much information can it handle? We're talking potentially thousands of deliveries happening at once, right?
Absolutely. In Paul's experiment, he was running 2,000 drone workflows and 2,000 order workflows simultaneously.
Wow.
All communicating through Kafka.
Okay.
And it handled it without breaking a sweat.
That's impressive. So it's like a super efficient messaging system, making sure nothing gets lost in the chaos.
Precisely. It's designed to handle huge amounts of real-time data, making it perfect for a system like this. Paul even created a visual simulation to show how it all works.
Oh, cool.
Imagine 20 drones buzzing around an island,
Okay.
picking up orders from shops marked as orange dots and delivering them to customers who are represented by red dots.
Okay.
When a delivery is successful, the red dot turns green.
So you can actually see the whole system working together in real time. That must be fascinating to watch.
It is. It really highlights the elegance of this approach.
Yeah.
You've got these different technologies working together seamlessly
Right.
to create a truly intelligent and efficient system. But there's another layer to this whole thing that takes it to a whole other level. Machine learning.
Okay, hold on. We've got drones, workflows, messaging systems, and now we're adding machine learning to the mix. How does that even fit in?
Well, think about it. What if you could predict which shops were going to be busy before the orders even started coming in?
Right.
You could position your drones more strategically.
So instead of just reacting to orders as they come in, you could anticipate demand and be one step ahead. That's brilliant.
Exactly. And that's where TensorFlow comes in.
Okay.
A powerful machine learning framework that can analyze all that data flowing through Kafka and learn patterns.
Wait, so it's like TensorFlow is watching what's happening with the orders
Right.
and learning how to predict the future.
You got it. It's using real-time data to constantly learn and adapt its predictions.
So it's learning as it goes.
Yeah, think of it like a brainy sidekick for Cadence.
Okay.
Helping it figure out where those drones need to be before things get hectic.
Okay, so TensorFlow is predicting busy shops. But isn't machine learning really complex? How do you even train a system like that, especially with data that's constantly changing?
That's a great question. And it brings up one of the biggest challenges in this area.
Okay.
Concept drift. Basically, it means the rules that govern the data can change over time. So what worked yesterday might not work today.
So it's like trying to predict the weather if the laws of physics kept changing. That sounds like a nightmare for a machine learning algorithm.
It can be.
Yeah.
But that's what makes this type of real-time machine learning so fascinating.
Right.
You're constantly having to adapt and refine your models to keep up with the changing world.
So how did Paul even approach this? How do you train TensorFlow to deal with all this crazy, constantly changing data?
Well, he set up a system where TensorFlow receives data directly from the order workflow via Kafka. It's constantly analyzing the incoming data, looking for patterns and refining its predictions.
Yeah.
And he actually had some pretty interesting results,
Okay.
even with a relatively simple setup.
Really? What kind of things did he learn? Was it able to accurately predict which shops were going to be busy?
It was, but it wasn't without its hiccups. One of the things he noticed was that the model's accuracy would sometimes oscillate going up and down over time.
Oscillate. So it wasn't consistently accurate. That's a bit concerning, right?
It was, but it actually led to a fascinating discovery.
Okay.
Turns out the model was picking up on some unintended biases in the data, specifically those related to time. Think about it. If you included things like the day of the week or the time of day in your analysis,
Right.
you might end up with some pretty strange predictions.
So it was like the AI learned to become superstitious about Friday the 13th. That's hilarious.
I think it's a good way to put it. And it highlights just how important it is to carefully consider the data you're feeding into these systems.
Right?
Even seemingly innocuous details can throw off the results.
So what did Paul do about it? Did he just ignore the time data altogether?
He experimented with removing those time-related features, and it did help to reduce the oscillation. But there was a trade-off. The overall accuracy of the predictions went down slightly.
So it's like a balancing act.
Yeah.
You want to avoid those weird biases,
Right.
but you don't want to lose too much valuable information in the process.
Exactly.
That makes sense.
It's a classic challenge in machine learning, and it's something that researchers are constantly grappling with.
So we've got Cadence keeping those drones in check, Kafka making sure everyone's talking to each other, and now TensorFlow trying to predict the future.
Yeah.
That's a lot to wrap your head around.
It is.
It is. But it all comes together so beautifully, right? We've got Cadence making sure those drones are flying smoothly and following their workflows. Kafka acting as the air traffic controller, keeping those communication lines open, and then TensorFlow using its smarts to predict where those drones need to be. It's like a perfectly choreographed symphony of technology.
It really is, and it speaks to the power of these open source tools. You can take these building blocks, Cadence, Kafka, TensorFlow, and create incredibly sophisticated systems that can adapt and learn on the fly.
So what does this all mean for the future of drone delivery? Is this the kind of system that could actually scale up to handle millions of deliveries a day?
I think it has the potential. We're already seeing the incredible things that can be done with these technologies, and we're only just scratching the surface. Imagine a world where you could order something online and have it delivered by drone within minutes, all thanks to these intelligent systems working behind the scenes.
That's incredible. It's like something straight out of a sci-fi movie. But it also raises some interesting questions, right?
Yeah.
What about things like safety regulations, privacy concerns, noise pollution? There's a lot to consider as this technology becomes more widespread.
Absolutely, and those are exactly the kinds of conversations we need to be having as we move forward. It's not just about the technology itself. It's about how we use it responsibly and ethically.
So what can our listener take away from all of this? What's the big picture here?
I think the biggest takeaway is that we're entering a new era of intelligent systems. Systems that can learn, adapt, and optimize themselves in real time. And this has implications far beyond just drone delivery. We're going to see this kind of technology being applied to all sorts of industries: transportation, healthcare, manufacturing, finance. The possibilities are endless.
It's exciting and a little bit daunting at the same time, isn't it? We're on the cusp of some truly groundbreaking advancements, but it's up to us to make sure we use this power wisely. It's a big responsibility.
It is. But I'm optimistic. I think if we approach these technologies with a sense of curiosity, responsibility, and collaboration, we can create a future where they benefit all of humanity.
I like that curiosity, responsibility, collaboration. Those are good guiding principles. And speaking of curiosity, I'm curious to know what our listener thinks about all of this. What are your thoughts? What other applications can you imagine for this kind of real-time adaptive technology? Leave us a comment on our website. We'd love to hear your ideas.
It's a fascinating time to be alive, that's for sure. The future is full of possibilities, and it's going to be amazing to see what we create together.
Well said. That's all the time we have for today's deep dive, but the conversation doesn't have to end here. Keep exploring, keep learning, and keep asking questions. Until next time, thanks for listening.